Hello everyone, in this video we'll see edit distance programming problem. Edit distance problem is a famous problem in string algorithms. It's not an algorithm, it's a way of problem solving called dynamic programming. So in this video we'll see a tabular method of dynamic programming. Most of the time dynamic programming will be the tabular methods. So here I have two strings, namely string A and string B. Here it's written as Saturday and Sunday. So what the problem is, I have to convert from string A to string B. If I am converting from this string to this string, how many changes I need? The changes in the sense you can insert, you can delete, which means removing the character, and replacing means updating the character. If A is there, I substitute it by B, this kind of replacement. So in this example we can see you have the same S is there, so S will come like that, and A I don't have here in this one. Here in this one example you can see D is there, Y is there, and U is there. So the characters mismatching is this A and this T and this R. So I need to remove these two characters and replace this by N. So this is the operation I supposed to do. So what I'm doing is I'm removing one character. Here also I'm removing one character and I'm replacing this one character, so that all other characters are remaining in this string. It's already you can see this now clearly. So when nothing is there itself, you can see this two cells are blank, which means that there is two characters must be removed from the string A. So in these kind of ways you can realize this. What's the usage of this kind of edit distances? You have genomic test, like DNA tests are there. So there are two sequence of DNAs are there, that's literally designed by AGTC, like that sequence is there, and you're finding out how far it is relevant. So you can find it out this guy is parent of this kid. Though those kind of genomic matching, some kind of genetic algorithms and all these kind of algorithms getting used. So this problem is a very important interview question. So we'll take a look how do we solve this problem. So what are the three operations I'm going to do is I'm going to remove a character, replace a character, and insert a character. I'm going to use a tabular method in dynamic programming. It's a 2D grid. The rows are defined by this string A, this side, and the column is defined by the string B, which is the string 2, which is Sunday. So how do we do this is first I construct this empty table called DP, which having m plus 1 rows and n plus 1 columns. So what are all the operations you can do is, I already told that you can replace, remove, and insert it. And here you have this cells to denote. This cell is called INJ, means the previous row which having the same column will be I minus 1 and j, and the diagonal one will be called I minus 1 and j minus 1, and the previous one in the row in the column called I comma j minus 1, which means the column is reduced by 1 here, and here both reduced, here 1 reduced. So how I'm treating these cells is Here you have a replace operation for this same cell. You can just go and overlap this in place of this one like this, so that you can understand this is for removing, and this is for replace, and this is for insert, and this is for the current one, which means I, G. Okay, now how the algorithm works is, if I have same characters, I no need to do anything, which means I can take what the previous best is, and I can continue this. So from where we can take that previous best is from the exact diagonal of this position, which means I no need to do anything, means you can just pick the what was there when completing the subset. And this one you can dynamic programming, you can you must know what is subset problem, and with using and solving the subset, how do we solve the main problem is. That's what the actual dynamic programming is entirely. This problem, what's the subset means, from the starting you have a sat like a phrase and a sun like a phrase. So what we have with solving this small problem, which means the reduced version of this whole big string to small string, you're solving the bigger problem. That's the reason we are going for this dynamic programming, which means the solving the small set of problems which leads to a whole solution. So how do we do that? Okay, now we'll take it. So we have one string, and we have one more string here, the string 1 and string 2. So here what I'm doing is, when I don't have a string, and here also I don't have string, so it is literally 0. I don't need to do anything operation in this one. Okay, I have this first string empty, and second string I have something, which means I need to remove these characters from this str2. So I have to do one operation, and when it comes to this cell, I have to do two operations, then n, then 3, d4, d5, and y6. This is how I have to fill. Okay, and when I have this character s in my, how do I do is, when I don't have any thing in my string 2, I have to do one operations, which means I have to insert it, which means here you can see that inserted. So before that, previously what first one we are doing is we are um, removing it, here now inserting it. Okay, now like that we have to insert 2, 3, 4, 5, here 6, here 7, here 8. Okay, now we have prepared our first row and first column. Okay, now we go to the actual algorithm is. So what we have to do is, I'm coming to this cell, and I'm standing at position 1 and 1. So but the string starts from 0, so I have to do I minus 1, j minus 1, but that's for only this string perspective, but we have to solve for this problem dp array perspective. So I'm standing here, and I'm looking this first character and this first character, both are same, so I no need to do anything. So whatever my previous result was in this one, which means the best of which is nothing but the diagonal one, I have to replicate that, because I don't need to do any operations, because this is same. So that's the reason we have written this when empty and empty it is 0, and this is one of the subset of this problem that we are solving. So I'm going to write it as 0. So okay, now in this one you can see yes and u, which means you have this one, and you have to remove this u. So what I need to do is, these two are different, and what I do is, my approach is, I'm taking the minimum of these three things. So literally you have to take these three things and how to add +1 because this character is not at all matching. So what the subset problem we have solved so far? +1. The reason for +1 is we are adding the character is mismatching. And why you are taking minimum? See, you can see this replace thing. Replacing means we are overwriting it. Replace operation you can do by insert and remove also, but we have to find this is as a minimum operation. So the replace is the best thing that, and you can do it in one operation. If you are inserting and removing and inserting a character, that is a worst thing. So that's the reason it is a minimum thing we have to take, and +1 since this character is a mismatching one. So in this one you can see which is minimum. You can guess this as a, you can see this as a 0 is the minimum and a +1, so 1. So which may make sense, right? Here when S is there and here is U is there, so from S to SU what I do is I have to add one more character as U, so that the string 1 will become string 2. So that's the reason which solves this problem. So next is also like that, and you have to compare these two characters, S and U, and what gives me is 1 plus 1 is 2, and here not matching, so 3, and here also, and now here it is 3 plus 1, so 4, and here it is 5, and now when it is moved here it is not matching, so I have to take minimum, and it is 1, and here it is, this 0 is there, so 1, here also not matching, so it is 2, here 3, um, here A and A are matching, so I need to take the diagonal value, so 3, and here it's not matching, so I can make this value as 3 plus 1, so 4. Likewise I quickly fill all the rows and columns by taking comparing minimum of it, and comparing these two characters, and quickly fill up all those, and it literally displays like this. So what and all the characters are matching I've given in the this cyan color, and other characters are in green color. So the result will be in the bottom right corner, so you can treat this value as the edit distance, and this is the answer. So we quickly jump to the Visual Studio and write the code for this. So the thing you need to consider is when we have to take the minimum value when the character is matching and character is mismatching. So only one if else case is the actual problem is. So we jump back to Visual Studio. So now we'll solve this. I need two strings, so I'm declaring a string A equals Saturday, and string B as Sunday. You can treat these strings as non-space. We have only plain English alphabet of lower cases. So, and we should have M and N. So int M equals A dot length, and int N equals B dot length, and I need array called DP. I'm just declaring it as 100 and 100, and I'm initializing it to 0. So now we have to fill the row and columns. So int, I'm filling it as equals as, and M dp of you have to write it as each row is changed, so 0 and equal to I. Even you can start it from 1. And next for loop, I'm writing int and j, which is n equal to n. I'm starting from 1 and dp of in the 0th row I'm filling it as jsj. Okay, now I have to write for traveling both rows and columns, and here equal to m, and for j equal to n, and if the character both are not same, so a of I minus 1, here it should start from 1 and 1, and equal to b of j minus 1. If that's the case, dp of I and j equals dp of the diagonal one, so I minus 1 and j minus 1. If this is not the case, you have to do dp of I and j equals min of dp of I minus 1 and j minus 1, comma dp of I minus 1 j, and from this minimum you can take dp of I and j minus 1. You can write one more min and plus 1. Okay, now your table is updated. Ultimately you have to print edit distance is dp of m and n. Okay, now our code is ready, and I just adjust these braces now. Okay, now format the document and run the code. The edit distance is 3, so we got the answer as 3. So this is how the dynamic programming for edit distance works. So you must be familiarized with these kind of problem solving. Will help you in answering interview questions. This is a famous interview question. You can expect this. And the thing you have to do is, how do we fill this row and how do we fill this column, and why do we take this min operations, and how do we fill this dp, and what's the subset. And when dynamic programming comes, the first thing you have to look at is what's the subset of this problem, and by solving the subset, how it can leads to the solution. That's the thing you must consider. Okay, I hope you understood this problem and solution, and we can meet in the next video. Thank you for watching.